Hi, this is a video on percent composition of elements in compounds. So every compound has elements in it, and we can calculate the percent by mass of each of the elements in a compound. This is showing you sucrose, which is table sugar. So I am going to show you how to do these types of calculations. So percent composition, like any percent, is always the part to the whole, and then multiply by 100. So what you do is you take the molar mass of just the element you're interested in, divided by the molar mass of the compound, and then to make it into a percentage, we multiply by 100. So these are the steps that we're going to follow. So the first thing you always have to do is determine the molar mass of the compound, then the molar mass of the specific element in the compound. So you would take the number, if there's a subscript, multiplement's molar mass, and then you'll take the element's molar mass divided by the molar mass of the compound. So let me show you an example. So this is dichlorine heptoxide, and what we want to do is calculate the molar mass first always. You can see that in this compound I have 2 chlorines and 7 oxygens. On my periodic table, molar mass of chlorine is 35.45, oxygen is 16.00. I'm going to add these together, and you can see that I am going to show you a little bit more work than I normally would on a molar mass. Right, I'm going to show you that this would be 70.9, and that this would be 112. And the reason I'm doing that, and then you have to add them, and I get 182.9 grams per mole. That's the molar mass of the compound. So to calculate the percent composition of the chlorine, for example, I'm going to take the mass of just the chlorine over the total times 100. When I do that, I get 38.8%. Then I would want to do the other oxygen, and again, that's why I did it this way, so I'd have it handy. So the mass of the oxygen over the molar mass of the whole compound times 100, and I get 61.2%. And then the cool thing is you can check if these should add up to 100, and they do. And if they don't, they should add up to really close to 100, because sometimes it can just be the rounding. Let me show one more type. Another type of problem is if you wanted to know just the percent composition of a particular element in a compound. So you still have to calculate the molar mass of the compound. I'm counting how many atoms I have. I look on my periodic table to get the molar masses. This time I'm going to only show my, sub problem. I don't know. I'm showing my work here just for carbon, because that's the number I'm going to focus in on. Although I do have to do the rest of the calculations. And when I do that, I should get a molar mass of 180.18 for that whole compound. So if I want to know just the percent of carbon, I could have done the hydrogen and oxygen too. But sometimes it's just a shorter problem to look at just one element. So I would take the mass of just the carbon over the total mass of the compound times 100. And when I do that, I get 40.0. So there is one on your worksheet I'll do with you just in case you're still struggling or want to see more. So barium nitrate. And when I count, you can see that there's 2 nitrogens and 6 oxygens, and molar mass of barium is 137.33, nitrogen is 1401, oxygen is 16. So this is one of the problems on your worksheet. So determining the molar mass, the percent composition of barium, nitrogen, and oxygen in barium nitrate. So the first thing you would have to do is calculate the molar mass of the whole compound. And then also you can see how I'm doing these little sub-calculations and showing my work just so it goes really quickly. So then I can say the percent of my barium is going to be the mass of the barium in the compound over the total mass, or the total molar mass. I'm going to do my calculations in a second. Nitrogen would equal 2802 over the total. And then oxygen, percent oxygen would equal 96 over 261.35. I'm going to pause it while I calculate, and then, so I took the mass of my barium, 137.33, over the molar mass of the compound and multiplied by 100, and I get 52.5. I took my nitrogen mass, 28.02, divided by the molar mass, times 100, and I get 10.7. And then lastly, the oxygen, which is 96 for just the mass of the oxygen, divided by the molar mass. And then if you were to add these, it looks like they're not perfect, but they're going to give you close to 100. Otherwise, you know that something went wrong. So that is it. I hope that helps you with percent composition.